The unit that we're beginning this semester is called exponential functions. This is different from linear equations that you've learned about in Algebra 1. If you look at the table on the left here, you'll notice that with each row, as x increases by 1, the y you add 3 each time, and that's the pattern for every linear function. Now, the exponential function that we're starting this semester is on the table, shown in the table on the right, and this is different from a linear. Do you notice the pattern? The pattern is that you multiply by 3 each time instead of adding by 3 in a linear function. The exponential functions, therefore, you can tell an exponential function because you multiply by a certain number each time, whereas for a linear equation, you add by a certain number each time. Exponential functions are useful in real-life examples. For example, population growth could grow exponentially. Money also grows exponentially. And in fact, this exponential growth model, which says y equals a times 1 plus r to the t power, this is a model of the exponential function. And if you compare it to y equals a times b to the x here, the a is the same, but the b corresponds to the 1 plus r in the growth model. And this is how the money in your bank account grows according to the percentage of interest that the bank is willing to pay. So in an example on the third page, when you purchase a new car, the amount of money that you pay is the initial deposit. That would be the A, which in this case is the 25. And the amount of money, the value of the car rather, is depreciated each time by 0.85 each time, which shows that it goes down by 0.15 every year, which is 15%. And so there is a 15% depreciation from the year that the car was new. So using the exponential decay model, which is the 1 minus r, you could use that model to answer this question and figure out what's the value of the car at a certain number of years after it's new. And you could also figure out when would the value of the car be a certain amount of money.